Yeah, so can you tell me what your name is and what you do at Geoship right now?
Yeah, my name is Bas. I'm a co-founder and designer at Geoship. And what I'm doing at Geoship is mostly at the moment, we've been working a lot on visuals, but also thinking through the interior design system and the details for designing this prototype.
Yeah, it's beautiful what you've done already. It's, as a investor, pre-order holder, it's really inspiring to see what you've done here. It really is.
You're very welcome. It's awesome that you came by.
Yeah. I was talking to someone about this. Like, what are your thoughts about having a basement, underneath this, for expanded kind of square footage kind of thing?
Yeah, what we're working on is kind of like call it the universal foundation system.
Okay.
That you can use just to build on a flat surface, like we have built this dome here, but where you can also choose to, for example, build it in a hillside and expand it to potentially basement and all sort of situations.
Gotcha. Have you looked into, I know this is really early to ask this, but into solar into the windows themselves? That's a fairly new technology. Not a lot of people are using it, but
we haven't really particularly looked into that. But it's the same as electrochromic glass. All these solutions are awesome, but so far usually they're only available for commercial use, just because it's usually pricey, and it's you need to buy a certain amount for it to be for
cost effective.
Yeah. And that's actually what's cool about Geoship, that will be possible, because with high volume production, all these kind of features that normally are only within reach for specific kind of architecture forms, then we can make them accessible actually for more people.
Right, that's really neat. I was looking at, do you have any idea how long and tall the interconnects between a small dome and a large dome would be? Or how, have you given much thought into that yet?
I'm pretty sure there will be a variety of possibilities there. It's we start with a small dome, and then we develop a big dome. And first we develop a small dome with an entrance kit, and then a big dome with an entrance, and then we develop this connector. And I'm pretty sure that at some point there will be a couple of connectors available, maybe more closed, maybe more glass, maybe longer, maybe higher.
So become maybe a combination between the ceramic and glass, as you want, really, right?
Yeah, just you see the dome, when you can exchange panels for glass or closed.
Right.
Just based basically on your geolocation, depending on where the sun is, how much passive solar you intend to have, and it's really about fine-tuning a system that can help people to decide what this optimal layout of their windows is for the exact location where they are. And from there on, of course, they can start to say, well, optimal is great, but I also have some desires for certain aesthetics.
Right.
And so from the optimal kind of energy efficiency situation, you can start to chip away a little bit to tune also the aesthetic.
Okay. Quick editor's note on the interconnects. I forgot to ask a question about, say you have a dome that you don't have a dome to connect it to. So say later you can expand your original dome, add an interconnect to that, and add that to a larger or smaller dome in the future as you need to. So don't feel constrained that you can only just buy one dome. You can always expand and interconnect it to other domes as you need to down the road. Is this facing south, the windows now? Or what direction is that facing?
The entrance is kind of facing southeast.
Okay.
East, southeast.
Have you noticed the dome kind of get warm from the sun from the inside during the day?
This prototype is not yet insulated.
Yeah.
So it's like we cannot like have for this kind of conversations. It's like we cannot compare this prototype to how it would be as in performance.
Okay.
But yeah, this prototype does not have insulation yet. We developed this prototype with a 10-inch insulation cavity. Where this prototype is most likely going to be filled with Havelock wool. That's like a fairly sustainable, non-toxic material. And we are developing like a cellular ceramic insulation. And that means like also your insulation can be can have a lot higher value than with traditional insulation materials.
Great. Have you done any calculations on like snow load for people who live in like high snowfall areas?
We actually haven't done the precise calculations. What we do know is that the geodesic is inherently like resilient. It's one of the strongest shapes known to man, as in triangles support each other and spread the tension over the whole dome.
Yeah, no, just with like with Pacific domes, that even those domes handle an incredible amount of snow load. I'm sure this could handle far beyond that.
Yeah, that's why we're not really concerned that that's going to be an issue.
Yeah, there's not a lot of places for the snow to even sit on it. Like maybe the top few triangles, but the rest of it seemed like it would slide off, right?
Yeah.
Have you given thoughts to about people that want a fireplace for their heating? Like if you could have like a vent for the stove in one of the panels?
Yeah, that's a good question. It's about like how our current systems for heating and cooling and integrated in this dome, just like water and power. And in most cases, it's fairly similar to a traditional home. You can have a wood stove and you have your vent or your stovepipe come out somewhere. You can also have radiant heat floors.
Oh yeah, that'd be nice.
Or it really depends on where you are and what your preferences are. But like any other home, any home you can use all kinds of like energy sources, water sources. This is similar, Of course, yeah, just like a regular construction.
Cool. Have we done any stress testing with the bioceramic, like impact, like say, like one of these branches fell off and hit it, what kind of impact do you think it would take, or would it kind of shake it off? Or I know you don't want to like break this thing, but have you given thoughts to that?
Yeah, a lot of these kind of particular measurements, we have done some form of testing and strength testing, but like to be really particular, same as in the snow load, is all for the next phase where we'll do a lot more engineering and simulation to like figure out all these aspects. What we do know is that with composite technology, where you basically bring fibers and the bioceramics together, we can create very strong surfaces, and again, the geometry helps a lot.
Yeah.
Because it's not only the point of impact, it's about how the whole structure then absorbs
energy.
Absorbs that energy, exactly.
But you could repair it just with the same material that it's made from, like a small chunk.
That's right. Kind of that's one of the main, really important qualities of the ceramics that sets it apart, and that's the self-bonding quality. And like concrete, you cannot glue wet concrete to dry concrete.
No.
It doesn't work. This material you can create waterproof cold joints. So that means that you can patch this thing up with the same material, and that's about repairing, and that's about resurfacing. So it's really about like longevity. What does it mean? That means repairability.
Right.
because things happen, and we cannot always predict that. But if you can repair it, then you can come a long way.
Yeah, and it seems like it's something the homeowner could do themselves fairly easily, right?
Yeah, exactly. You can just mix up some ceramic.
Yeah, because there's what I love about this versus like a traditional home. There's the structure is everything. There's no roof to replace. There's no paint because the color is embedded all the way through it because like the pigment's mixed in with the ceramic. It's just, I love it.
Yeah, this kind of home is really like the coming together of a material science that has like incredible qualities. It's non-toxic, a lot stronger than regular concrete. Waterproof, cold bonding, has a fast set time. That together with this incredibly resilient geometry. Resilient and efficient geometry that creates for a really high quality home.
How long is the set time for like each kind of triangle or chunk?
For each component.
Yeah,
the set time for each component, the material can be tuned to have really fast cure times. And that's exactly why this material is so suitable for mass production.
So you can just pump it out really quickly, and they're all totally the same part essentially.
Yeah, that's really also what's so awesome about the geodesic dome. Imagine building a home from this, let's say, 10 or 15 different parts.
Yeah, that's amazing. Because all the triangles are sorry, go ahead.
Yeah, if you imagine to make a home from like a limited set of parts, that all precision engineered and come precisely together like on site where you're building it.
Yeah, because all the triangles are the same size on this prototype.
There's two different triangles in this prototype. You can see it here is a pentagon.
Okay.
And there you see a hexagon, and so there's
I see.
two triangles make this whole dome.
Okay. Very interesting. Then you have more of like this square or rectangle to kind of connect it to the foundation.
Yeah, to lift it slightly up and to create a little bit more space.
What have you learned from building this prototype dome that you'll kind of take into the next one that you build?
We have learned a lot, like so much about. So building the prototype has been a lot about testing like the material, different mix designs, but also about different molding technologies. So different parts have been made in different ways to experiment with like how does it work? And so what we did, this prototype basically a foundation for the next iteration. We, with a pretty small team, we produced this prototype. And now we're almost ready to start hiring to expand the team with material scientists, engineers, and really like step it up, because it's really about more. We need more minds, experienced minds, to come together to think about the details of what we developed the foundation for.
Right. So your recent crowdfunding ended. What are your goals with that funding for your next step? Is your next step like to build the next prototype, or is it to hire more people, or kind of a mix between those?
It's a mix. So the next step for development is really to expand the team, to get the expertise we need in the materials, in the product engineering, in the tooling engineering. Okay. And the result of that will be more prototypes, because and some will be partial prototypes to just test small aspects of it, and some of them will be full-size prototypes, because it's not only the making of the parts, it's the whole design of the product and how the product fits together, how easy can we make it to build it and to lay it out and to just build it on your land. and to really like fine tune all these aspects, because one of the really important things for us is that we can build this, or that we design it in a way that an owner builder with a little bit of experience should be able to build this. So we're engineering all these parts to be in a certain weight range, so individuals are able to deal with the parts. There's no heavy equipment needed on the building site. It also means that you can bring these things to hard to reach places.
Oh, right.
And
that's huge.
And because of all the components, because all the components are basically precision engineered, it comes together like perfectly.
Right. That's very clever. Have you had any ideas of how to like approach bigger investors to kind of get larger funds coming in, other than the crowdfunding? You said you're going to do another crowdfunding through a different medium.
Yeah, what's important for us is to keep crowdfunding rolling. It's really important that we open the playing field and really create a movement of people that are really passionate to create regenerative villages, and that want to support the regenerative world that we need to create to live here in harmony with nature and in community together. So that's a very, very important part for us. Next to that, we'll also be raising money from accredited investors, and together I think we can make this work.
Yeah, and just walking up to this from our short hike it really does fit at home with the landscape. It's very inviting. You just want to go in it as soon as you see it from a distance. It's really kind of heartwarming to see it. Can you explain how the internal hubs kind of connect everything together? Are they made from the same bioceramic material as the dome?
Yeah, good question. This dome is 100% ceramic structure or bioceramic structure. One thing to know about the prototype is that how this thing is made with like the hubs and the struts is the way that we designed for this prototype. That was basically the design that helped us to learn.
Okay.
How the next iteration looks, probably quite a bit different, as in from an engineering standpoint. Visually, there might not be that much change. So how the hubs and the struts work, at this point it's more like a skeleton build where you put the panels on the outside and on the inside of the frame.
Okay.
In the future there might be a frame, there might not be a frame. There's many kind of paths that we're like walking to make sure that we're not like make sure that we're coming to like the best solution here.
Right, from building it and also assembly.
Yeah, from building, from assembly, for structural integrity, for waterproofness. That's often what people wonder with domes, like how waterproof they are.
Yeah, I think I was talking to someone after yoga. He was an engineer, and his thought immediately went to those like 70s wood geodesic domes that everybody hears how they leak, and I think that's just because those were made from wood and those shift, and there's a lot of the roofing, and I could see how that could be a nightmare, and that I think some of that stigma is still there from those times, and I think that needs to be made clear to people that these things are structurally sound, they're not going to leak, things like that.
Yeah, and with time we'll put all the proof on the table, once we have really like honed it in. And yes, Buckminster Fuller himself apparently said that they were building wooden spaceships in the 60s and 70s. And so he kind of predicted it would be 50 to 100 years for the right material science to come around to build domes properly. And we think this might be that.
Yeah, I would say so. I saw on the website that I know it's not on this prototype, but that you envision there being like venting at the bottom and the top to kind of circulate air in? Is that going to be like powered fans like hidden in the walls to kind of move air when you want it to, kind of thing?
That can be the case. Domes also have a very natural kind of airflow, and so the whole HVAC of how it works in a passive way and in an active way is both on the table.
Okay. I saw this YouTube video. I think it was like in the Alps or something. It was like this really tall, slender building, but all the windows faced south, and they had these windows that on the outer edge that I think it was like maybe salt that would absorb the heat during the day, and then it would like liquefy, and then at night it would kind of solidify and it would ooze heat into the interior at night when it's wanted. And maybe that's a possibility to kind of line the edges with that if you do want that kind of like passive heating from the sun, like if you live in colder places maybe.
Yeah, well, one of the interesting qualities of the ceramic is that it blocks or reflects 80% of radiant heat.
Oh, okay.
And that's good to keep it cool on the inside, but also good to keep it warm on the inside. So
keep the temperature you want in there to be stable.
Yeah, exactly. So you need fairly little power to actually like heat the place, and you need very little power to cool the place.
So once you have the heat going, it stays in there pretty well.
Yeah.
Are there reasons why you picked the current dome size that you have listed? I think there was a 32 and an 18. Maybe you plan on like expanding those sizes later, or are those kind of to be determined?
Yeah, this prototype is actually 16.
For interior space?
Yeah, the interior diameter is 16, outside diameter is 18 foot. We thought it would be a great size, but we also realized that that the final version of the smallest dome would probably be a little bit bigger than it is now. And why we started with this? Simply because it's good to start with a small dome to develop it.
Oh, of course.
It's like we need to start small, develop small, and slowly we get bigger. So yes, there will be different sizes. At the moment we show 2 different sizes on our website. There's a chance that we have big chance that we also introduce a bigger size once we're done with that.
Like a 36 or.
Yeah, who knows what the exact diameter will be. But.
Yeah, I was inside a 36-foot dome, and it was just massive. It was just really neat to be in. The ceilings were just higher than any building I've ever been in, or house I've been in.
That's the same with this,
How high is the vertical in this one?
About 10 foot.
Wow.
And even with this dome, it's only 200 square foot, but when you're in it, it feels
bigger.
Feels so different than 200 square foot. It's just one of these qualities of domes, that the expansiveness that you feel inside.
Yeah, when I stayed in, just sitting in there, you feel like you're being held by the earth. It's kind of hard to explain. You don't get that as often in kind of traditional built homes, like modern homes. It feels more stark, kind of cold, I guess you could say. But this feels like really warm and inviting.
Yeah, living in the round shapes has traditionally, like lots of tribes have actually built round homes.
All right.
And so, there's just very different kind of qualities around living in a round space. And I'm really, really excited for more people to be able to enjoy that. Yeah.
Oh, this is hard to answer, but people would want to know about shipping costs. Could this be shipped on a flatbed all in one go? They set it up, I would imagine so, because when this is all flat, it probably doesn't take up how many trips did it take to bring this stuff up here to build it?
I cannot answer that question because we didn't actually package it really efficiently or anything. as we're just making parts and slowly building it.
Oh, yeah, that's fair.
But we are designing exactly for that. So how these things can be shipped easily, can be packed as flat as possible, so that you can put like these small ones, there should be at least a couple of them fit in a container.
Oh, wow.
Yeah.
Okay. And it would come with like instructions with where I would assume like the final goal would be like the interior hubs would be like labeled how to stack them and whatnot, put them together.
Yeah, there will be, of course, clear instructions of how it comes together, how you build it. And I mean, today we live in a day where like augmented reality is being used to repair cars, to do all kind of things. So imagine that there will be all kind of support levels available from full installation for you as well.
Mm-hmm.
But to really like make sure that like I mentioned, like the owner builder can build it, that anybody can basically build it themselves when they have a little bit of experience and insight. We're really trying to like design this thing so that can be done. And the support systems, like yes, augmented reality, it recognizes the part and tells you where to put it. And it can of course also be on a drawing.
Just looking a little bit into like homes, a lot of the cost is just building it. That cuts into a lot of the cost of people wanting to have their own home, is just paying someone to build it, even though the structure may be simple. You're not able to do it themselves unless you're like licensed. And this is a huge game changer to have like a large group of friends help you build a exterior structure fairly quickly, reasonably, I would say like a week or something, or how long?
Yeah, probably something like that, and maybe even faster, especially for a small dome like this. Yeah, when you have 2 experienced people, you should be able to put this thing together maybe in a couple of days.
Wow. And so this is going to be built to international building codes, so when you have like permitting in certain like counties, they want, whatever, so they kind of pass all those kind of tests. You'd have like what is it called? Engineering report you could provide to kind of show proof of that.
That's one of the things that's important for us, to really make that process easy. First, yes, engineer to international building code. It's the material, even if we call it the bioceramic, under the code is actually the same as a high strength concrete, classified as a high strength concrete.
Okay.
So that makes things a lot easier already. It's not rocket science for the code. And of course there will be a lot of testing being done, and all that will be provided to support the customer, but also the licensing or the permitting departments to like support everybody in what in their job. To make it easy to get these things certified. And of course there will be you will need engineering stamps, because it's not like it arrives put together on site and they just need to drop it off.
Sure.
But when we can really make sure that this thing comes together in a good way, then that's all not going to be a big deal, we believe.
Yeah, that would be huge. I looked into just like yurts as a primary structure, and like looked in Pacific domes for a while, and it was just, I hit hurdles because a lot of counties don't allow, they call them like temporary structures.
Yeah, it's exactly.
And this obviously is not a temporary structure. It's built to last, and I feel this, I think the only pushback, some places I looked to live, like they didn't like the shape of the dome, and that's kind of unavoidable in some like HOAs, for example. But some counties I talked to, they said, we don't care what it looks like as long as it passes, code.
that's the general attitude, you know. Sure, there will be certain kind of places or neighborhoods where your neighborhood association or something would say, or historic district, where there's certain kind of regulations, or a group of people decides on what the aesthetics supposed to be. But in most cases, we believe that won't be so much of an issue. And also, it's important to understand that we don't need everybody to want domes right off the bat, because we're just starting, and these domes will slowly start to appear in more places. And it's already like that. Companies like Pacific Domes, but also festivals like Burning Man, have been radically popularizing like alternative shapes and things. So people are getting more and more familiarized with alternative geometries.
That's true.
And yeah, I think we build our traditional homes are basically just 90-degree angles. And it's three-dimensional geometry, but it's very kind of basic three-dimensional geometry. And so I believe that this is also kind of, imagine people starting to live in more complex geometries, how that would slowly influence our thinking and our understanding of these more complex geometries.
Oh, absolutely. You could probably like route electrical inside the cavity where there's insulation.
Exactly. There's more than enough space for all kind of routing of electricity, and water and plumbing can either go to the wall or to the floor. Very, very much like a traditional home.
Yeah. It's like the water could be in the walls, it's like if you're in a place where like the water doesn't freeze like to temperature, but if not, it could go through the floor. That's cool. And if you wanted to access what's behind the panels after everything's put together, could you like take like one interior panels off to kind of get in there for whatever reason?
Yeah, at this point these panels are removable, the ones in the prototype.
Okay.
And we don't know exactly what the different reasonings would be to keep them removable or fix some of them or all of them.
I think you said, what was your estimated like R value after you get insulated? You have like a goal?
Our initial calculations with like a cellular ceramic foam, we think we can get to like an R60.
Wow.
And that's for the roof and the walls.
Because it's all kind of the same.
Yeah, exactly.
Because what are most homes are like 20, 30, 40 at the most?
Yeah, it's important for us to make sure that what the government sets as a standard, not to take the minimum as a granted.
Yeah.
You know, let's engineer something that's really lives up to, let's engineer a home as a product that's really like high quality. Because that's really basically what this technology enables. And not right off the bat. Affordability comes mostly with scale, but to create a home that's just ultra high quality and is affordable, it's like that is the goal. And especially today with this insane housing crisis, it's like we cannot just build the homes that we need in the traditional way. That would be like a big mistake. And so that's why it's important for us. We call it often we're mass manufacturing natural homes. Because natural home building is like beautiful and it's an awesome technology like cob, straw bale. And you see the homes that people make out of that, and usually they're beautiful, well thought through, really well insulated, lots of good qualities. But most of the time it's simply not achievable because it takes so much time and so much money to build natural homes that in the situation where we're now at, it's just not realistic to actually think about let's build natural homes for everybody, because it's already a very exclusive thing that is only accessible to some people.
Right. I agree.
And this is really about affordable natural homes. Everybody should have the right to live in a home that's good for them, good for the earth.
Yeah, that's exactly what I'm looking forward to. Is there anything else you'd like to share as the frogs chatter in the background?
What's interesting about Geoship is that we're a company, because we believe that a company is simply the best tool to bring a vision to the world today. If you see where are the power structures in the world, that you see corporations have so much power in the world. So imagine us building a cooperative business for that has a positive impact to the world. So the business is not the purpose. The business is the tool to be able to bring this vision to the world.
Oh, yeah, that's a good point.
And that's what what sometimes people get confused about, because we're a business and we're asking for investment, which so many people have bad experience with business, with corporations, that it's an interesting place to be, because how do you communicate? Well, we actually doing this in the best way we can and choosing the best path based on the time that we live in to bring this vision to life.
Sure. I think people are seeing that more and more, especially with startups like yourself that are transparent, showing. I think what a lot of people have trouble with corporations is that there's a lot of secrecy or things behind closed doors that they don't like. I think a lot of startups are open to share what their vision is and getting people to invest early. So people could potentially make money by helping you in the process.
That's the idea.
It's like a win-win.
That's the idea. If you invest in Geoship, it will generate a return that you then can use to create more good in the world. Mm-hmm. That's how we try to think about it.
Yeah.
This home is it's a product, and it's a modular product. Means, for example, you can choose where you want the windows yourself.
Right, I forgot to ask that.
You can choose where you want the windows. You can connect different domes. You can connect different dome sizes, either with outside walkways or with covered walkways, and with indoor walkways.
I like how you've placed the windows on this one, how you're going to have that half circle of windows. You have the three in back, and then I thought there was one in the front too, over the doorway. Is that right?
Yeah, that's correct.
And there's some lower ones as well. So a lot of natural light. I like that.
Yeah, that's important. If you look at what's important for living, is connection to the earth, connection to light, and the feeling of spaciousness and high ceilings. All these things really contribute to, just contribute to the experience.
Well, thank you so much for your time. I know it's late. Thank you for your patience.
My pleasure.